For years, the development of open-source video AI was constrained by a data ceiling of less than 1 million hours. That constraint has now been expanded by an order of magnitude. The strategy that built massive open image models, scraping billions of URLs and filtering them into a public corpus, has finally been applied to the video domain. This timeline shows the scale of previous open video datasets. InternVid was the previous high watermark, offering 760.3 thousand hours of footage. LAION-BVD reaches 10 million hours. It is roughly 13 times the size of the previous largest open source. The release provides a unified source for 3 different modalities, containing data for video, as well as audio and static images. This volume changes the open video model race from a data acquisition challenge into a data processing challenge. Because 10 million hours are now available to any researcher, the competitive advantage moves to whoever has the raw compute and the synthetic captioning quality to make use of it. The dataset begins with 1.3 billion platform-specific video URLs, pulled from the March 2024 Common Crawl dumps. To process these links, the authors used a distributed setup of 2,000 virtual servers, routing their traffic through a residential proxy network. Even with that infrastructure, the yield was limited. Out of 130 million download attempts, the team saw a link success rate of approximately 60%. This resulted in a final raw count of 80 million downloaded videos. When you look at the source of these videos, 94% of the URLs point directly to YouTube. This heavy centralization makes the dataset vulnerable to link rot. Because URLs die every month, anyone attempting to recrawl this list today will find less success. The dataset is a decaying snapshot of the open web, its utility permanently tied to third-party platforms. From 80 million videos, researchers used scene detection to split the pipeline into 2 tracks. The primary track produced 55 million clips, each with a synthetic caption. The secondary track extracted 300 million scene-changing frames as a separate image text resource. To validate these frames, the team measured their Frichet inception distance. This metric confirms these video frames occupy a different visual distribution than standard web images. The synthetic labeling was generated by Qwen3VL Instruct, a 2 billion parameter model. The model faced a strict budget, 20 words or less per video. The audio side used Audio Flamingo, restricted to a 10-word budget. If you find these deep technical deconstructions of AI datasets useful, subscribe to the channel. The sheer volume of clips is unprecedented, but the descriptive bandwidth per clip is limited by the word budget of the small captioning model. In zero-shot tests, models trained on BVD subsets outperformed the heavily filtered InternVid dataset by up to 4 percentage points. However, the researchers could not match InternVid's published scores when using their own independent pipeline. The gap was explained when a GitHub discussion revealed InternVid's results used a technique called WiseFT. WiseFT is a test-time merging strategy. Instead of using the trained model alone, you average its weights with the original clip weights at evaluation. Applying this trick lifted the baseline model's performance from 58.0 to 60.2. The audio validation shows a different limit. While BVD matches standard audio datasets at scale, it falls behind specialized mixes. At the largest model scale, a curated mix of LAION audio and audio set beat the bulk BVD data 56.6 to 46.8. While bulk scraping provides competitive baseline performance, undisclosed test-time merging and manual curation still define the state-of-the-art. Synthetic datasets have a mathematical limit. Student models inherit the specific blind spots of the model that captioned them. Any visual detail the 2 billion parameter Qwen model cannot identify, or cannot fit into 20 words, is effectively removed from the dataset's supervision. When comparing zero-shot performance on ImageNet, a model trained on Datacomp 1B scores 0.58. The same model trained on BVD frames scores just 0.28. This represents a 50% reduction in accuracy, a direct result of the limitations in the synthetic captions and the visual coverage. The authors note that this data has not yet been tested on generative tasks like video language models or the fusion approaches. The true test will be observing whether video synthesis models plateau early when they are trained on these short 20-word descriptions. Short captions may provide enough signal for contrastive classification, but they are thin supervision for models tasked with generating complex, moving pixels. There is a contradiction in licensing. While the dataset release uses a CC BY 4.0 label, the 80 million underlying videos are still protected by the copyrights of the original creators. Because of this, the raw video files are kept behind an institutional gate. Researchers must sign specific terms of use to access the data. Regarding safety, the paper states that no additional safety filters were applied during the collection process. The researchers outsourced safety moderation to the native filters used by platforms like YouTube. Shipping 10 million hours on the assumption of platform safety is the same oversight that led to the recall of the original LAION-BVD. Relying on it again suggests the cycle is likely to repeat.